Hi, my name is Antonia Leung and I will be recapping the lecture from yesterday. In the beginning of the class, we continued working on the previous lecture's example to find the range of possible omega values. From where it was left off last time, we first found the equation that represents the force of friction. Then, we found the minimum omega value by plugging in and rearranging equations. Finally, combining with the maximum omega value we found yesterday, we got the solution. The next part of the lecture is about linear viscous friction. It is defined to be the friction between two lubricated objects. The equation for this friction force is negative c multiplied by v, where c is the damping constant with a value larger than or equal to 0, and v is the velocity. This can be used to model oscillating motions. The lecture also covered springs. A spring is defined to be a one-dimensional, deformable body with length L. The force exerted by a spring on the body is tangential to the spring at the point of contact. Some variables associated with springs are L0, which represents the resting length of a spring, x, which represents the difference in length after the spring is no longer resting. It can be calculated with the equation x equals to L minus L0. K represents the spring constant. S represents the spring force. For linear springs, the spring force can be calculated by multiplying negative k by x. This is also known as Hooke's law. The unit for spring force is newtons per meter or pounds per feet. For nonlinear springs, there are two types. Softening spring refers to those that slows down as force increases. Hardening spring refers to those that resist more and more exchanges. For parallel spring, the spring constant is equal to the sum of individual spring constants. And for springs in a series, the inverse of the spring constant is equal to the sum of the inverse of individual spring constants. We started an example with springs. We need to find the range of possible x values in the example. To do that, we first drew three body diagrams to find the values of different forces acting on the block. Then, we did kinematics, which was simple because the block is at rest. Next, we did dynamics calculation to find the sum of forces. And lastly, we broke the dynamics equation into components to solve for the normal force N.